Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to you all. My name is Associate Professor Dr. Ahmad Umaizi bin Hilmi. I'm the co-founder of Software Thesis, which is the software that I created by myself, and my brother Ahmad Zaim is the programmer for this Software Thesis. Okay. This is my first time doing live in TikTok. Okay. I hope I can learn something new lah from this live. Okay. I'm going to do the lecture on flexibility analysis in manufacturing system, which is among the subject that I'm going to teach for the master student. Okay, I hope the audience can get some information from this topic. Okay, from this topic. So the topic that I choose is introduction to flexibility analysis in manufacturing system. Okay. Okay, what is flexibility analysis? Flexibility is capability of manufacturing system to adapt to changes in product type, volume or process. It is vital in dynamic market where demand and technology evolve rapidly. Flexibility enhances competitiveness by ensuring system can respond to fluctuation without sacrificing efficiency. In energy-intensive industries like heat treatment, flexibility optimize resource while adjusting to variability energy inputs. Okay, this adaptability is crucial for sustainability, especially in industries facing unpredictable condition. Okay, this is the means of flexibility, meaning that there are uncertainties in your factory. How you to become flexible? Okay, how do you become flexible? There are types of flexibility such as process flexibility, product flexibility, volume flexibility, and routing flexibility. Okay, so this is what you will learn throughout this subject, throughout this lecture. There are historical development in flexibility analysis, such as flexibility analysis originated from efforts to manage increasing complexity in manufacturing. Earlier pioneers like Grossman integrate flexibility with optimization techniques to address uncertainties in industrial system. Okay, modern tools have expanded flexibility beyond manufacturing with application in electronics like wearable device. Okay, computational models such as MINLP. Okay, multi-integer neural language processing have refined flexibility analysis of offering powerful insight into production feasibility. Okay, so flexibility as a competitiveness factor in modern manufacturing, because you know that now in manufacturing sector, you see your handset, it is frequently changing. Once the brand come out with a new brand, after a while it will come out with a new brand. It always change. It's always change. Okay, this is the flexibility. Okay, as common, that's why flexibility is an important tool right now. Okay, so we go to the second slide. I have made two books. Okay, I have made two books about flexibility analysis and also situation-based flexibility analysis. You can find this book in Amazon.com, and also you can see the profile in many of my profiles. Okay, you can see in my profile in the TikTok. Okay, that I have put the link for all my books. Okay, so you can see here the types of flexibility, okay, there are types of flexibility in manufacturing. There are process, volume, control, and routing flexibility. Okay, process flexibility is ability to adapt manufacturing technique to suit various products and requirements. Product flexibility supports technological innovation like equitable energy distribution in smart logic local energy system. okay, SLES, volume flexibility enables system to scale production down or meet demand fluctuation efficiently, and routing flexibility allow alternate process path, reducing bottlenecks and ensuring operational continuity. Okay, so flexibility F competitiveness factor, you can see here that we must adapt to market demand. Okay, manufacturing system must be flexible to respond to demand fluctuation, regulatory pressure and technological advancement. Okay, for example, your handset, smartphone, okay, always changing. For example, nowadays is electric cars, electric vehicles, electric motors. They all keep on changing, keep on coming on the new technologies. Okay, so energy storage system improve flexibility by optimizing a production during periods of fluctuating energy demand. Okay, let's say for the festival days, okay, the demand is high. Okay, let's say for the night the demand is not that high. For the day the demand is high. Modularity in process design, modular system enhance flexibility by enabling independent operation and minimize the risk of system-wide failures. Okay, fundamental concept of feasibility and flexibility analysis. Okay, for example, feasibility in modular manufacturing, like this researcher have done, Bosika and Ira Petrierto 2021. They use mixed integer neural language processing model to ensure system feasibility under varying condition. Okay, and then feasibility based optimization, Tian et al. Introduced techniques for maintaining operability in dynamic uncertain condition and flexibility in supply chain. The Chang et al. Emphasize flexibility in copper concentrate industry, optimizing real-time operation. Okay, so there are index and flexibility index and feasibility index. Okay, how do we quantify the flexibility? Okay, there are two index here. The one feasibility index and number two is flexibility index. Okay, flexibility index in design process, like Ochoa et al. 2021 present flexibility index formula to evaluate adaptability under variable condition. And then Kurienko et al. 2024 apply Bayesian methods to identify feasible operational regions in batch sector. And geometric flexibility index, Zhang et al. Introduced the volumetric flexibility index. Okay, FIV for non-convex phase adaptability. Okay, this is the index. So that's using this index we can measure whether our system is flexible enough or not enough flexibility. Okay, okay, there are methods to measure flexibility in management system. This is what the purpose of the master level punya class I want to teach. Okay, there are mathematical and simulation based method to identify the flexibility in your system, which is the mathematical modeling by Babazi et al. 2020. They develop framework to quantify flexibility across demand scenario. Okay, for simulation for energy flexibility, they use Oakleek et al. 2022 uses simulation tools to assess energy adaptability in manufacturing process and flexibility score. Rocher et al. Proposed a score for energy system quantifying flexibility in demand side management. Okay, so this is among the methods to measure flexibility. Okay, and among them, with the advancement of artificial intelligence, there are machine learning based approach for flexibility estimation, like linear model decision tree. Okay, and Marie et al. 2023 they use decision tree to as surrogate models to enhance optimization efficiency in flexibility analysis. And then there are deep learning in demand response by Bopati et al. Employ regressive neural network and cumulative neural network model to predict load flexibility in energy system. And gene expression programming, okay, Hu et al. 2020 apply GEP, gene expression programming, for decision rule, optimizing capacity expansion under uncertain demand condition. Okay. And then the topic number 3 is flexibility, design for flexibility, modular and agile manufacturing. Okay. Modular process design for smaller parallel units, optimize cost and timeline while balancing flexibility and scalability. Okay, like skin space at all. Supply chain optimization, modular system enhance flexibility in supply chain by balancing flexibility and feasibility through mixed integer NLP model, okay, by Boshika and Ira Potrio 2021, and use deep learning for demand response, deep learning model and flexibility in real-time adjustment in energy consumption in manufacturing. Okay, so even the design needs flexibility. You can see in your front of your eyes. Okay, the smartphone is, for example, the nearest to you is the smartphone. Okay, the smartphone is always changing. Okay, so they must be flexible in design. Okay, that's the nearest example for you lah. Another example you can give is electric vehicle. Also have to be modular because all the changes must be done in faster time. Okay. So computational tools for flexibility analysis. So they are using volumetric flexibility analysis. Okay. FIIB metrics to analyze flexibility in non-convex system using cylindrical algebraic decomposition CAD. Okay. And they use optimization in reactive separation like mixed integer optimization, enhance flexibility in reactive separation system, maintaining efficiency under varied condition. And then there are batch reactor flexibility analysis, optimization based method to ensure batch reactors remain flexible under uncertainty. Okay. And then flexibility in retrofitting manufacturing system. Okay. For example, the things that you have to remove and you have to remove and to your assembly back, which is called retrofitting. Okay, like heat recovery system, two-step optimization model, enhance flexibility in retrofitting heat recovery system, balancing efficiency and operability under varying conditions. They are done. This research is done by Langner et al. 2021. Energy management from foundry simulation tools help improve flexibility in energy-intensive foundry process, allowing for adaptive energy consumption, and refine all pipeline flexibility using mixed integer MILP model. Refine all pipeline logistics system, optimize flexibility for cost effectiveness in dynamic condition. Okay, it is important for you to become flexible, for your company to become flexible. Okay, and for you also yourself to become flexible because you can fit to all the system. Okay, so mixed integer linear programming MILP. Okay, for flexibility optimization, for enhancing flexibility in manufacturing system like copper concentrate operation. For this is some case study lah they use. Check et al. Demonstrate how MILP, mixed integer linear programming, optimize scheduling under a certain supply and demand condition in copper concentrate operation. It provides dynamic flexibility, improving efficiency and reducing risk. Okay, modular manufacturing, Boshika and Iropetro extend MILP to modular manufacturing, optimize trade-off between centralized and distributed production for adaptability in meeting product demand. Chemical process design, explore the use of MILP in modular chemical batch, reducing cost and maintaining flexibility. What is the similarity between these three types of companies? Because the supply demand is not in control, not in their control. Because, like for example, copper concentrate operation, is no uncertainty that the copper will come in time. Maybe there is accident on the road. Maybe there are accident on the shipping on the ocean. Maybe there is war going on. Okay, the supply cannot come in time. So what shall we do? Okay, this is the things that we do not know. So how to become flexible on this? Okay, simulation based flexibility analysis in manufacturing, flexibility in energy consumption and robotic system. Okay, they are using heat treatment flexibility. Okay, they are using energy flexibility in battery production. Okay, and then they using robotic flexibility. Okay, for example, heat treatment facility, Ogling et al. 2022 use simulation to analyze flexibility in heat treatment process, helping to manage energy consumption in the under fluctuating demand. Okay, and then energy flexibility in battery production. Bach and all use analyze energy to use flexibility in battery production chain, enabling manufacturer to optimize resource utilization. Because nowadays, electric vehicle become rising popularity now, right now. So they how to optimize the battery usage in the electric vehicle. Okay, normal cars, thermal combustion engine also have battery. Okay, how to distribute the battery, so battery power into all the cars, all the car system. Okay, robot system flexibility, of course if you are lucky enough to work in robotic company, robot also need energy consumption and everything, so there are simulation to make the robot make it better lah. Okay, and then life cycle assessment and flexibility in sustainable manufacturing. Okay, life cycle management, like material selection and flexibility. Tata et al. 2022 applied life cycle assessment LCA to roofing material, showing how flexibility in material choice can reduce global warming potential across product life cycle. Okay, because we come with the power of the sun. They become wear and tear, become heat, and then how to choose the material suitable for that, because on the roof system we want the roof to become as long as possible. Okay, we want to use that our roofing system as long as possible. Okay, that's why we choose the must be flexible in choosing the material. Okay, solar drying system, explore the flexible solar drying system enhanced by energy storage, ensuring sustainable operation during periods of low demand, and carbon footprint optimization, integrated flexible analysis with carbon footprint assessment to design low carbon product and simplify design process with minimal environmental impact. Okay, so case study in flexibility tools. Okay, this is the case study. Previous slide also case study. Now focus on case study. So volumetric flexibility in process system, Zhang et al. Introduced a method to using CAD. CAD is not for computer aided drawing now. It's the term that you can see in the previous slide. Okay, introduce a method using CAD to measure flexibility in system with non-convex flexibility space, improving adaptability under uncertainty. Surrogate models for flexibility, Amari et al. Demonstrate the use of surrogate models like decision tree to enhance the flexibility in multi-stage manufacturing system, increasing computational efficiency. And modular design for energy efficiency, while all use modular design to optimize hybrid deep borehole heat exchanger system, improving energy flexibility and scalability without sacrificing performance. Okay, flexibility in smart manufacturing and industry 4.0. Okay, now we are talking about industry 4.0. Okay, everything 4.0. Okay, smart manufacturing adapts introduction to production changes via Internet of Things, AI and automation. Energy flexibility, Leader et al. 2022, flexibility for energy grid using industrial process, and AI predictive model, Bopati et al. Use forecast energy consumption, optimizing schedules. Okay, so flexibility in and digital twins in real-time manufacturing. Okay, it is what is digital twin? It is a digital replica for real-time monitoring, simulation and optimization. Let's say you have a factory, you sit in your office, you observe what the factory are doing in your office. It is a digital twin. Okay, energy flexibility with digital twin, Bob et al. Digital twin optimize the energy used in battery cell production. Flexibility in process design, and Tin et al. Enhance flexibility in complex manufacturing design using digital twins. Okay, AI and predictive model for flexibility and maintenance. AI now, we of course you heard about ChatGPT, Gemini, and all other AI tools that help to write thesis. Even I created software thesis. It's not that AI yet right now, but furthermore we plan for AI. okay, software thesis that I created with my brother. Okay, AI in predictive maintenance, Che et al. STM model predict maintenance machine performance, ensuring system flexibility. AI in energy system, Chen et al. Robust optimization industrial energy system for renewable energy flexibility. And AI index, ultra flexibility index use with AI ensure system adaptability to varying controls. Okay, case study application of AI in flexibility analysis, like Amari et al. Use surrogate model simplify complex optimization process for flexibility, and AI for energy flexibility, Knox et al. 2022 AI models ensure fair energy distribution in smart local energy system. Okay, integrating flexibility with lean principle. I'm sure there are another subject that you learn in another class about lean Six Sigma and everything. There is another subject that maybe inshallah I will cover later on. Okay, lean principle, enhancing adaptability, flexibility analysis allows lean system to adapt to changes in demand, material availability, or workforce capacity while maintaining efficiency. Flexibility support just in time. Okay, flexibility ensures lean system can adjust in real time to resource availability, minimize overproduction and delay. Studies supporting flexibility integration, research by Leader et al. 2022 and Shen et al. 2020 shows flexibility role in optimizing operational efficiency under changing condition. Okay. You see Six Sigma and flexibility improvement, enhancing process quality through flexibility. Okay, flexibility in Six Sigma help manage variability, allowing for better control over uncertainties in production process. Like I said before, we cannot control we plan to control the supply of raw materials, but actually we cannot control because maybe, God forbid, accidents happen, war happen, like Russia and Ukraine war right now. Okay, all these uncertainties happen, it will affect the production process. Okay, so how do we manage it? Okay, real-time adjustment, Six Sigma tools identify inefficiencies and flexibility allow adjustment to maintain quality of dynamic environment. For example, if you have many aircons in your factory, which aircon has down is non-operatable. Six Sigma tool can identify which point, which aircon there is problem, that you can go for the repair on the aircon. Okay, process optimization study. Tian et al. And Chen et al. Show how flexibility can optimize operation under uncertainty, ensuring Sigma levels are maintained. Flexibility in waste reduction and process optimization. Okay, we want to reduce waste with flexible manufacturing. Flexibility in waste management, it helps manufacturers to adapt to waste resource such as excess inventory and or efficient resource use. Energy and resource optimization, flexible strategies optimize energy consumption, reducing waste in resource heavy process like heat treatment. And studies in waste reduction, research by Ulik et al. And Schiller 2020 explores how flexibility enhance waste management in lean system. Okay, this is a case study lah on the flexibility analysis in lean manufacturing. So predictability analysis, flexibility, okay, Bupati et al. Demonstrate how predictive model enhance flexibility in demand response system. Okay, maintaining functionality under varying condition. Peng and Du discuss flexibility in wearable antenna design, similar to how lean system maintain quality under changing condition. And risk and uncertainty management, OCHA et al. Explore Nobel Flexibility Index for assessing system capability to handle variability. Okay, emerging technology impacting manufacturing flexibility. There is a term called LSTM, which is stand for long short-term memory. LSTM for model predicts operational parameters in high-speed manufacturing, allowing real-time adaptation. Surrogate models like decision tree, it will reduce computational cost while ensuring the manufacturing process remain adaptable under variable condition. And AI-driven technique for responsive AI system help manufacturing respond to changing production demand by supporting flexible capacity extension. Okay, and the role of flexibility in continuous and adaptive system, autonomous manufacturing, adaptive control and robotic, autonomous system in process control, autonomous system adjust operating parameters in real time to ensure resilient operation amidst changing variables. adaptive system for uncertainty. Flexibility-based optimization helps adaptive system handle operational uncertainty while maintaining efficiency. And robotic flexibility, snake-like joints with flexible joints navigate confined industrial space, enhancing precision and complex environments. Okay. And then flexibility in sustainable and green manufacturing. Okay. For the green manufacturing, okay, enhance energy flexibility in sustainable system, solar drain system, energy storage technology help manufacturing adapt to variable energy input, reducing environmental impact. Thermal flexibility in decarbonized plants. Thermal flexibilities help optimize energy consumption in decarbonized gasification plants, ensuring efficiency while reducing emission. Flexibility in renewable energy system. Robust optimization enables manufacturing system to adapt to fluctuating renewable energy source like wind and solar power. Okay. Feature research and direction within flexibility analysis. There are advanced flexibility analysis. New metric like volumetric flexibility index for more comprehensive measures by equating more non-compact flexible space. Okay. And then integration with predictive analysis. Machine learning model can forecast production needs and enhancing flexibility by reducing downtime and inefficiencies. And flexibility in modular system. Modular chemical process design allow reconfiguration based on demand, enhancing flexibility in production scale. Okay. And then, okay, now we go for the calculation. Okay. This is the general equation for flexibility equation. Okay, in for those who wonder what is the equation for flexibility, okay, this is the equation Fj z theta, okay, and then for j, so Fj represent the j's constraint function, z is the vector of control of design variable, theta is the vector of uncertain parameters that affect system behavior, m is the total number of constraint. Okay, I've written this in my book. Okay, define uncertainty region. This is the theta equal to theta. Then this is the upper and lower bound of uncertain parameters. And then you have step 3. They have to do there are step 1, there are step number 2, and there are step number 3, which is the feasibility design. System is considered feasible if all values of uncertain parameters within the region theta where there exists variable z satisfy all the system constraint. Given for a given set of variables z, the system is feasible if fj z theta lower than 0. So this is the condition ij im. So, and then there are flexibility index. Set number 4. Okay, is the flexibility index is the measure of how much variability in uncertain parameters theta in the system can accommodate while still remaining feasible. It indicates the size of feasible operating region relative to uncertain parameters. A common definition of flexibility index F if F equals to sup minimum this equation, and this optimization problem seek to maximize the set of uncertain parameters theta for which there exists control variable z that ensure system remain feasible for all constraints. Step 5 is surrogate models in flexibility analysis. Surrogate models such as screening, radial based function or neural network are used to approximate the system constraint fj z theta in situation where actual constraint function are computationally expensive to evaluate. Okay, the surrogate model replace fj with an approximation fj, simplify the feasibility and flexibility equation. Using surrogate model, the flexibility index can be approximated as this equation, f equals to this equation. Okay, and then you do the step 6. Step number 6 is the last step, which you do the sensitivity analysis to ensure the surrogate model provides reliable flexibility estimate. Sensitivity analysis is often performed to test the impact of varying parameters on the model prediction. Sensitivity analysis involves evaluating how changes in uncertain parameters data affect the system constraint and flexibility. Okay, so the general flexibility equation, this is the equation the general form of flexibility equation, and combines system constraint, uncertain parameters and flexibility index. Okay, so this is the equation. So that's okay, this is the general index lah. F equals to integration of n and I p I per di dot a1. Okay, this is one of the example given. Okay, if you do join this class, there is an example, and there is calculate the flexibility index for manufacturing system with 4 stages. We have speed, PI, demands, DI, machine abilities. A given as P1 is 100, P2 is 150, P3 to 200, P4 is 250, and do all these parameters. Analyze how 10% increase in demand across all stages affect the flexibility index, and propose optimal machine ability I for each stage that will maintain or increase the flexibility index by 5% from the original value. Okay, so this is the step for to solve this question. Okay, this is the step. You can find the original flexibility index is 3.547, and then you step number 2, calculate the flexibility index after 10% increase in demand. Okay, so after increased demand, you can get the flexibility index is 3.15. Okay, and then propose the new machine availability. So the new increase by 5%, target flexibility index is you can F original times 1.05, you can get 3.64. New machine availability required to achieve this target flexibility are new, this is the number lah. Okay, 0.995, 940 and everything. Okay, all these are given in the video, in the book. Okay, I hope this book that I created, the book that I created, what is the book? These 2 books, I hope it will give benefit to you lah. Okay, that's the end of this lecture. I hope some of you will benefit for it. Okay, I hope you can get some benefit from my lecture. Okay, insyaallah I will do more better videos. This is the first time I'm going to live in TikTok. I will learn from this experience. Okay, I will make it better and better. Okay, Assalamualaikum warahmatullahi wabarakatuh. We meet again insyaallah. Okay.